Okay, hello everyone. You should see my screen, and I'll talk about two parts today. The first one will be more general purpose, how to work with fiboa, and the second one is more for data publishers or creators, and answers the question like how can I easily create a fiboa compliant data set that you could also publish then. Um, so all what we are talking about today will be in this GitHub repository. So I'll quickly try to find the chat and share the link with you if you want to follow it on your second screen or so. But otherwise, we will post the script and the videos later online so that you can follow them later as well. What we'll start with is, well, heavy CLI hacking, let's say. And the first thing you will need is Python, of course, so Python 3.9. And then you need to install the fiboa command line interface, which goes through pip install fiboa cli, and then the version that we need here for this exercise. And do that, and then I had it installed already, but then you can of course check whether it's there, right? It's fiboa minus version, and then yes, we have the right version installed here, and can go ahead. So that's just for initial setup. If you want to see like how the CLI look, like what commands are available, just type fiboa minus help, and you'll get an information about the commands that are available, right? And then if you want to have information about specific commands, you can also like just type fiboa, then the command name, and then minus help again, and then you'll get the options that you can pass. So of course, the first thing that you would want to do is to look into an existing data set. And as Michelle has shown, there are a couple of data sets available on Source Cooperative in the organization. And then each of these has a link to the actual data set, which are all GeoParquet files. The command that we can run then, once we have the URL or local file, we can run fiboa describe and then put either a local file or a GeoParquet file on S3 or HTTPS, and then run that. It will download the file in the background in this case, and then output a couple of information for us that might be interesting, right? So for example, which GeoParquet version are we using? How is the geometry column called? Which fiboa version do we use? Which extensions are implemented? How the columns look like? And then output an example of the data here that is in the GeoParquet file. Just that's an excerpt, right? This has 200K columns or rows, and these are the information that are in the first 10 rows here. So that gives us a first impression. If you want to know like or see a little more, then you can just type minus n 100, and you get 100 rows. If you want to just type or see specific columns, for example, the ID, then you could use minus C ID and minus C area, for example, then you just see the first 100 rows and with the columns ID and area. You can also like type minus J, and then you get an excerpt of the JSON metadata that is included in the file. Right, and that is now a lot of information here. So you get all the GeoParquet metadata, which is a lot. Then the collection metadata, which is available here, which includes a bit more information about the title, the description, the license, etc. And then 100 rows of IDs and for the other thing, area in hectares. So that gives us a first impression. Of course, you can also like load the file into QGIS and show it there. I mean, it's normal GeoParquet file, so that's always an option as well. That gives you a first impression. If you are more into Python coding, you could of course also use the CLI, the code behind the CLI to load data. This is a bit all like still a work in progress, but it gives a first way into working with the data. There's potentially more to do to release a full fiboa Python package that can like be used in Python directly without like interfacing with the CLI. But just for the sake of it, you of course need to install the CLI before you can use this, but otherwise you can go through this, right? Import the fiboa CLI utils package and then the function load parquet data. And then we have a couple of parquet files from source here that we could load, all with different CRSs. So what we need to do, or just for the demo purpose, we just load a single parquet file here and just show like the first 10 rows again, or 5, whatever. It's 5 here, to give an insight into it. Looks pretty much the same as before. But now to use fiboa for something more useful, we define like the map with all the URLs, and then the next row just downloads all the files to disk. I've done this before so that we don't need to wait here. And then once that's done, right, we can load all the files that we have here, fiboa files, into memory. And also, of course, need to align the geometries to have the same CRS so that we can like all use them in the same data frame. Before, like all the files in non-fiboa way were like not really aligned with each other. So the column for the area was different. The geometry column was called differently. Some were potentially in hectares, some in other units. So that wasn't really aligned. And what this helps us now with is to do things on top of multiple data sets at the same time. So now it's loading that into memory here, and we merge that all into a single geodata frame in the end. While that's running, yeah, that's done now. And then what we do now is we have all the data in memory, but need to merge it together. So we're doing that here via the pandas concat function, and have then here 1,200,000 rows combined. That's mostly over Germany and Austria. I think I've excluded Austria for the sake of being a bit faster in the demo. And now we can show all the polygons using the Python package Lonboard, which should give us a map of the area in Germany that the packages are from. This takes a bit because it like visualizes 1 million polygons on the fly here on my computer. Let's see. Yeah, there we go. There we go. Like here is the visualization of like all the boundaries. We can zoom in here and see all the boundaries. And you see also the properties if you hover over them that are in the geodata frame for each of the boundaries. Okay, so that's that. Now, of course, the nice thing about fiboa is that we can like have the same field all over the place and all the same data. So we can now, for example, do something like, hey, what is the largest field size in Germany that we have in our data set? So that is here, for example, the largest one is 500 hectares. Or we can do statistics like or lists of the information, like what are the 30 largest fields by area in Germany. Do that and then sort them. And then we see, oh yeah, these are the 30 largest fields in Germany, right? Most of them seem to be in Brandenburg, Berlin, some in Niedersachsen, and yeah, right? So to get a better sense of that, we can also like visualize it again. And then we see here, oh yeah, these are the largest fields that we can see, right? Of course, as we've seen, the specification still needs to evolve, and there are only a couple of extensions right now, but over time, this should, of course, allow us to expose more and more fields in the same way, so that we can even do even more statistics, computations on top of data that is all harmonized with each other. Yeah, so this notebook is there for explorations, all in the fiboa tutorials folder here. There is a load fiboa Python notebook that you can use. Yeah, that's the notebook. Now, another thing that, of course, if you download data or if you create data, one would want to do with the fiboa CLI is, for example, to validate whether the data is actually valid. And you can do that with the fiboa validate command. So you just type fiboa validate and then the URL or a local file, run it, and then it tells you whether the file is in principle valid to the fiboa specification. Tells you which version it is, which extension it checks. Some fields that are not standardized via fiboa, it will complain or say that there is no schema defined, of course. These fields can't be checked, of course, because there is no schema defined. It also says that by default, due to the size of some of the files, it doesn't check the data itself. If you want to do that as well, so that it checks whether like all the values that are in the file are compliant to the schemas, right? So if you have, for example, a file that should be a row that should be a column that should have a schema with numbers between 0 and 100, it will check whether these values are actually between 0 and 100. You can run that with minus data. And then it takes a bit longer, of course, because it needs to load all the data and then check whether the data is valid. There are a couple of additional options that you can use that are mostly for some specific use cases in development cases where you can, like, for example, provide the specific path to a schema, because by default, of course, it loads the schema for the released version 0.2. But if you're in development cases where you want to update some parts of the schema or map to an extension that you developed right now, there are a couple of options like -s, -e, etc. That you can use if you want to explore those. As before, fiboa validate --help, and then you will see that the options are available here. And run them. As they are pretty specific, I'll not go into details how to use them, but if there are any questions, of course, always ask questions in the CLI repository on GitHub. The other important thing probably is if you try to create data, you might have just GeoJSON data or GeoParquet data, and then you want to convert between the two. There is also a command to create a GeoParquet from GeoJSON and the other way around from GeoParquet to GeoJSON. That's the other way around, yeah. To show how that works, in the repository that we have here, there's also a folder features that has a couple of features in there just for demo purposes, which we'll use now. And what you would do is here you just type again fiboa create GeoParquet, specify then at the next step the folder that you want to read. Then it reads all the GeoJSON files out of this folder, and then -o gives you where you want to store the file. So that's done. It complains again that there are, of course, some things that are not defined yet. For example, the flick and the nuts code and the nuts.txt are not defined in fiboa yet. So we'll default to some default data type for the column and then write it to test Parquet. One thing, of course, you might have seen that before, is that there are extensions to fiboa, and the flick extension is there, which is a specific type of ID in Germany for field boundaries. So to remove this flick, no schema defined warning here, we can actually tell the converter that there is a specific extension that we want to use. So instead of what we had here before, we add -e and then a URL of a schema identifier that is part of the extension. You can run that as well. And then it doesn't complain about flick anymore because now the flick field is actually known by the converter and validator. Right, this flick extension can be found here in the fiboa GitHub organization as well. And there is a property defined flick which directly says what this is, how it's structured, etc. So that's created now. The first thing, of course, that we want to do now is to check whether the data that we've created is actually valid. So we type fiboa validate again, check the data as well. And now, oh, it says me it's invalid. And it tells me why it is invalid. So it says it's longer than the maximum of 16 characters and doesn't match the required pattern. So what we need to do now is to go into the folder with the files and then check what's wrong there. So here are the files, and it tells me that, oh, it doesn't tell me yet. I still need to check. So let's have a look into the file actually. So it says here there is a string which is invalid. And I'll quickly run the describe command again and see here, okay, this looks a bit squishy that it is not aligned here. But what we want to look at here is the ID. So here it says it ends with 84. Here it's 84. So we need to look into the file with the ID 2713. So opening that, let's see what's wrong there. Oh, there it is. Oh, and we see here is a space that accidentally got in here. Let's remove that. And then try again. So we'll create with the same command that we've used before the Parquet file and wrote it. We can validate it again, and now it's valid. Yeah, so that's how to create GeoParquet files. And we can, of course, now check or do the opposite pretty much. And from the GeoParquet file that we created, we can just create JSON files again, so the other way around. And this works, well, here is an issue in my script. So I now need to fall back to doing that on my own. So it's GeoJSON, create GeoJSON, and then the input file is test.parquet. And we want to output this into the, let's say, temp folder. And I think that should be good to go. Yeah, let's try that. Okay, files have been written to the temp folder. Let's see where that is. It's here. So we got a feature collection with 2 properties. Doesn't look very good right now, hard to parse as human. So let's get back to the CLI and tell the CLI to actually indent the files with 2 spaces. That's -e2. And what we also may want to have is 2 separate GeoJSON features instead of 1 large feature collection. For this, we could add the -f flag, and that we can run. And then what we see here, we get the 2 features and a collection JSON with the metadata for the collection that was in the Parquet file. If you want to look into that, here we go. So now we see there is the GeoJSON file again that we had before as well, with all the properties included here, the geometry, etc. What we can also do, of course, is to try and check whether what we did is actually, let's say, the same. So the old folder and the new folder that we created, so the source files and the file that went twice through the conversion, we can compare. I have a tool here that does it for me. And if I select them and say compare, we can have a look here. And it's pretty much the same, except that like the parser obviously did like sort the entity, like the properties here. So we see the area is still 1.897, etc. The flick number is still here. So that's all the same, just differently sorted. And it added a link to the collection file, but otherwise the file is all the same. So we can go from GeoJSON to GeoParquet and back. Let's have a look. What's next? Yeah, so that's the basics of the fiboa command line interface and how to work with fiboa in Jupyter notebooks. The next part that I'll talk about now is how we can actually convert data from an existing data set into fiboa with the conversion framework. So if you're more into the data provider side, then this might be more interesting to you. If you're more into working with the fiboa data, then this was your part. Good. Any urgent questions right now that are open for this part?
Hey Matt, just a quick question. When I play with a notebook, I do find a module not found error, which is while trying to do the visualization. Anything else I can try? I put a message in the chat box.
Yeah, I guess we need to solve that later due to time constraints, but that would be something we need to look into. The visualization is relatively, let's say, is a recent addition to the Python ecosystem and is like working on the edge with technology. Visualizing so many things might, I guess, error in slower systems, but yeah. Ideally, open an issue in the tutorial section, and we can with the error message, and then we can look into what the actual issue is. I don't see a message right now in the chat, but yeah.
Gotcha.
Thank you.
Matthias, does the validation check for geometry, that geometries are valid as well?
It should be, because it's in the background there is a GeoParquet validation going on, but that's something I need to check actually. Yeah, it would check it against the schemas, like all the other columns are checked against the schemas. I'm not 100% sure whether the geometry actually gets checked, but that's a good point that I need to look into. It should be, but I'll investigate.
Okay.